Hello students, welcome to the science class. This video lecture is based on the topic conditions necessary for combustion from the chapter Combustion, Flame and Fuels. Now that we have understood combustion, which kind of substances undergo combustion, now what do you think? Do you think that combustion can happen just anytime we want? So any substance, maybe a paper, will just start burning on its own anytime? Had that been the case, then every time it would have been fire everywhere and everything would have got burned by now. But that doesn't happen, right? For a paper to catch fire, there are certain criteria which needs to be fulfilled. So only when those criteria are fulfilled, only then the process of combustion can actually take place. So here we'll talk about those three important criteria without which combustion can never happen. And what are the three criteria? The first is a fuel. A combustible substance is needed because until and unless you have a combustible substance, obviously which object will catch fire? So you need to have a substance which catches fire. You need air. Why do you need air? Because as I have mentioned in the previous lectures as well, that oxygen is extremely important for combustion to take place. What happens during combustion? The substance reacts with oxygen. So without oxygen, there will be no reaction. There will be no energy released. And the third criteria is heat. Now the question is, why do we need heat? We need heat because we need to increase the temperature of a substance to a particular temperature so that it can catch fire. Now we are going to talk about each of these points in more detail one by one, and we'll see that how each of these criteria is important for combustion to take place. Now the first point, that is combustible substance. This we have already discussed, that not all substances readily burn. So those substances which easily burn to produce a lot of heat and light, they are called combustible substance. And one such combustible substance has to be present for combustion to take place. For example, wood, coal, petroleum, etc. So now we'll talk about the second factor, that is air. Why is air necessary for combustion? Now, in order to understand this, what we will do is we'll do a small experiment, or we'll do a small observation rather. So for this, what we need is a candle which is already lit. So with this lighted candle, what we do? What do you see right now? A candle is lit. It's perfectly glowing. The flame is seen distinctly. Now I take a glass and just put the inverted glass over the candle. What happens? The candle still glows for some more time, but after some time it goes off. The flame goes off. Why? Why did this happen? Because we did not do anything to blow off the candle. So whatever you observed till now, do one thing, just note down the time for which candle was lit, even after even after the inverted glass was put over it. Initially it was glowing. We put the glass, it still glowed for some time. So let's note that time. Let's say that it glowed for some time, say t1 seconds, and after that it went off. So why did it go off? Because when we have put this glass, we have actually limited the amount of air which is being provided to the candle. When the glass was not there, there was plenty of air surrounding the candle, so it was utilizing the air and the process of combustion was taking place. But now, when we have put this glass, so it's only that much amount of air which could be accommodated inside this glass. So only this much air is available to the candle. So the candle utilized all the air which is present inside the glass. But after that, there is no air. When there is no air, there is no oxygen. When there is no oxygen, no combustion can happen, and therefore it just went off, right? So that's the first set of experiment which tells us that air or oxygen is necessary for combustion. Now we'll do little more experiment to the same thing. Now what we will do is, I'll take the same candle, but now I'll change the glass. I'll take the bigger glass. So when you take a bigger glass, what happens? Again the candle will glow for some time, and note down the time in this case. So let us suppose that this time the time is say t2 seconds. Now what you will observe here is that this time the time for which the candle was glowing before it again goes off, because here also we have put a limitation. So it can only utilize the air which is there inside the glass. But what we observe is T2 is greater than T1. That means the time for which the candle lighted in the second case is more than the time for which the candle was on in the first case. Why? That's because in the second case the glass was bigger. In the second case it was a big glass, and in the first case it was a small glass. So when the glass was small, there was less amount of air, so there was less amount of oxygen available. So therefore the candle put light only for some time. But in the second case the glass was bigger, so larger amount of air was present inside the glass, so larger amount of oxygen was present. Therefore the process of combustion could happen for a little longer time, and therefore the candle lighted for a little longer than case first. So this experiment further proved that air plays a very critical role for combustion. Now the third criteria, that is heat. Why is heat needed for combustion? Now before we talk about it, let's think of some simple scenarios. So think of a matchstick. How does a matchstick catch fire? Does the matchstick catch fire on its own? No, we need to put in some effort. What do? We have to strike a matchstick against the rough surface of a matchbox. So only when we do that, it catches fire. Why do we strike, and why is that needed? That's because when we strike a matchstick with a matchbox, there is friction, and friction produces heat. And when this heat is produced, it increases the temperature of the matchstick, and when the temperature increases, it catches fire. So basically what this example tells is any combustible substance catches fire only when its temperature reaches ignition temperature. Now you might ask, what is ignition temperature? So we'll talk about it just now. So it basically means that it's not that any substance will catch fire just any time on its own wish. So the substance will catch fire only when its temperature reaches a particular temperature. So in order that the temperature reaches that temperature, it has to be provided with some heat. Only then the temperature will rise, and that's why heat is needed for combustion. So ignition temperature is the lowest temperature at which a substance catches fire. Now this temperature is not same for different substances. Every substance will have its own ignition temperature. There will be some substances which will have very low ignition temperature. So low ignition temperature means they can very easily catch fire because already the ignition temperature is low. It's like your passing marks. For example, in your school the passing marks are 40 out of 100. In another school the passing marks are 30 out of 100. So if the passing mark is lower, then it's easier to pass, and if the passing marks is say 60, then it's more difficult to pass. In a similar way, if the ignition temperature is very less, it's very easy for that substance to catch fire because that temperature where it gets ignited is very less. If the ignition temperature of a substance is very high, then it will not catch fire very easily, right? So what do we say? Substances with low ignition temperature catch fire more easily. So now I think you'll be able to understand why do we need to strike the matchstick because when you strike a matchstick, friction is involved. Friction provides heat, and this heat increases the temperature of a matchstick so that it's able to reach its ignition temperature. So this is how we find that three criteria are very important for combustion to take place. That is a combustible substance, heat and air. Thank you and have a very good day.